Welcome back to the channel. Actually, I've been not asking you guys to subscribe, but it's not such a bad idea actually to do that. Please do subscribe to stay on the loop so that you can always maybe see what I upload. And yeah, click on the notification bell so that you get notified next time when I upload. That's provided you are interested with the content that I upload. So yeah, we are here. We are being asked to find the equation of the tangent to the circle that is given by the equation at this point. So a tangent is at that point. That is basically the point where the tangent intersects with the circle. So because a tangent is a straight line, if we are being asked to find the equation of a straight line, we definitely know the target is to come here. Y equals to mx plus c. If already we know one point on this straight line, we can try to use, because there's only one point that we know we have, which is on this line. We can try to use this other format, y minus y1 equals to m into x minus x1. So this format, if we were to try to use it, because look at this one requires us to know the y-intercept as well as the value of m, which is the gradient. But then the second one, it requires us to know the value of m, which is the gradient, as well as just one point on the straight line. We already have one point on the straight line, so it's better to just deal with this one, because this one we don't know what that value is. So we're gonna first start here. What we do, we substitute that point. Let's substitute the point. The point has its y value as 2, and then its x value, it's actually 4, just like that. And we can tell that when we simplify this thing, it's going to be y minus 2 equals to mx minus 4m. That means we are left with y equals to mx minus 4m plus 2. So if we can know what m is for this equation, then we are just going to simplify further, and ultimately it's going to be in this format, as you can see there. So we need to know how we are going to get this m, the gradient of this tangent. At this point, we can't really proceed with just the information which is provided for the tangent alone. We need to implement the use of the other information that we have been provided. The information that we have been provided, it's about the circle. How is that going to help us get the gradient of the tangent? It's actually going to help us in this way. Remember, when you have a circle has a radius. Wherever that radius touches the tangent and the circle, yeah, I'm just trying to draw a straight line there. They are perpendicular. I know this is not a straight line, it's so many lines, but I try to just show a straight line. This is a tangent, this is a radius. Wherever they meet, they are perpendicular. So if they are perpendicular like that, should we be able to know the gradient of the radius? Then we can say the gradient of the radius times the gradient of the tangent equals to -1. Then from here, we'll be able to say that the gradient of the tangent is equals to -1 divided by the gradient of the radius. So let's try to find the gradient of the radius, because this point is the given point, which is 4 and 2. And this point, we can just write this in standard format, then we'll know what the coordinates of the center are. From here, we are able to determine because we'll have 2 points, we're able to get the gradient of the radius. So let's do exactly that. Okay, first thing, let's use this or rewrite this equation of a circle, and then plus 2y equals to 0. We're going to try to convert it into the standard format. To do that, we just need to complete the square as usual. To complete the square, we take the coefficient of that, we divide it by 2, we get -3. That -3, we need to add it on both sides, like that. Y squared plus 2y. We take the coefficient of y, we divide it by 2 first, then we get 1. We square it, add it on both sides. The 0 on the right hand side, we're going to add -3 squared plus 1 squared. Okay, and that will mean on the right hand side, what are we having? That is 9 plus 1, which is 10. On the left hand side, we're going to have y plus 1 all squared plus x minus 3 all squared. So the coordinates of the center are actually going to be +3 and -1. So we know the coordinates of the center, therefore we can be able to calculate the gradient of the radius, which is going to be let's say this y value minus that y value there, which is -1. That's 2 minus -1 divided by 4 minus 3. What is this gradient? That is basically 2 plus 1, which is 3, divided by 1. So that is 3. Okay, therefore the gradient of the radius times the gradient of the tangent equals to -1. How do we substitute? We have 3 there times the gradient of the tangent equals to -1, and then from there the gradient of the tangent is equals to -1/3. So now that we know the gradient of the tangent, we just need to bring that gradient of the tangent, this one, back to our equation here. So we're gonna substitute, substituting that, we're gonna just say that's y equals to, okay, let me just zoom out a bit so that we can see. It's gonna be -1/3, okay, x minus 4 into -1/3. Okay, actually this bracket was supposed to be outside like that, and then plus 2. So we're gonna have -1/3x, and then -4/3 plus 2. What is that? That is actually positive 10/3. So that is your equation of the tangent. Then we are done. I hope I got it done. So I'll see you in the next video. Thank you for watching. Like what and then